I would like to welcome you on the third meeting of BioRural, where we exchange knowledge about agriculture and food systems. We will have 3 days meeting. On the first day, we will hear about basic concept, techniques. On the second day, we will show you a good practices, factors of success. And on the last days, we will talk about cross-cutting things. I'm representing, and some of my colleagues here represents Institute of Soil Science and Plant Cultivation. We are a state research institute. We work with broad range of activities which comprise soil science, crop production, economic, farm effectiveness, environmental modeling, climate changes, spatial analysis, renewable energy, microbiology, biochemistry, plant biotechnology, hop and tobacco production and breeding, as well as bioeconomy. Today we're here because of the BioRural project, which was founded under Horizon Europe. We started work in September 22. We will continue on working until August 25. The project includes 19 partners from 14 countries. Our main goal is to develop European Rural Bioeconomy Network. We work in 4 regions of Europe, trying to encourage rural stakeholders to use more bioeconomy themes. Within the project, we have selected several success stories with who we are working. We try to analyze the success, how they became so well recognized, and what is the secret. We try to multiply it for other actors which we are identifying during the project. A part of that, we also built an online tool which provides scientific and practical support to stakeholders. We have collected a lot of inventories, fact sheets, those success stories, recordings out of those workshops which we proceeding right now will be also stored in online tutorials. But the most important thing, this is a tool for many actors, for farmers, small businesses, where they can register, they can get contact, they can get information. So I encourage you to take a look of it. It is really full of interesting information. In the chat, we will add in a second, or we already have added, as I cannot see, the link to this toolkit. You're very welcome to be part and work with us. For now, I thank you very much for your time and being with us. I would like to inform you that this meeting is being recorded, and those records will be later stored at the toolkit that I just presented. And now I would like to ask Grzegorz Siebielec, who work a lot with soil science, soil remediation, land use change, nature-based solution and waste management. I will just share Grzegorz presentation now. So Grzegorz, the screen is yours. Let me know when to change the slides. Thank you.
Okay, thank you, Magda, for this introduction. So my name is Grzegorz Siebielec. I'm a soil scientist I'm leading soil science and land protection department here at the Institute of Soil Science and Plant Cultivation. And as a soil scientist, I'm happy that soil is the agenda of that bioeconomy meeting and biorural project. Well, soil, there is no future without soil. So this is the basis for the food sector, food production, uh, climate change mitigation, and for sustainable development. I will start with a short description of a soil mission, because soil is currently, and we are happy of that, at the high level of interest in the European Union and high level of discussion. Uh, so we went quite long way from soil understood as only as a production function to a range of functions provided by soil, or ecosystem services provided by soil, and the role of soil for sustainable development of the whole globe. So the mission is a program, certainly for Europe, that would lead to transition towards healthy soils. Healthy soils means the soils able to provide all the ecosystem services. This will go through funding the research and innovation, creation of a network of at least 100 living labs and lighthouses dedicated to soil management, to improve soil management, developing a harmonized framework for soil monitoring in Europe, because we have to know what is the state of soils, and raising all people awareness on the importance of soil, because we need contribution of all the entire society to the improved soil management. So next slide, please. And the central point of the EU soil mission are living labs and lighthouses. These are certain platforms of innovation and co-creation. Co-creation is the most important word here, because living labs combine various stakeholders, various interests to develop the best possible solutions in terms of soil management, and contribute to societal challenges. Thanks to that inclusion of society and various stakeholders in the co-creation process, and at the end, to improve soil health and related ecosystem services through the improved soil management. And another aim of the living labs and lighthouses is to demonstrate good practices in soil management, because examples always tell more than any written word about soil. Next slide, please. So these are 8 major objectives of the soil mission: to stop negative processes observed in connection to soil cover, soil resources, and almost all of them, or all these objectives, can be somehow connected to bioeconomy. The reduction of desertification, which is because of climate change and decline of organic matter in soil, and we, through bioeconomy, we can send more organic matter from biowaste to soil. And another goal is to conserve soil organic carbon stock. Quite clear connection to bioeconomy through fertilizing soils with alternative and safe bio fertilizers, stop sealing and increase reuse of urban soils. This deals, for example, with improving soils in urban areas through soil amendments, reduction of soil pollution, enhanced restoration. There is quite clear synergy with bioeconomy through reduction of input of pollutants to soil and enhancing restoration of degraded soils using biomaterials, for example, preventing erosion, improving soil structure through application of waste, bio-waste, drift, organic matter, and overall reduction of footprint on soil. We assume that it would be reduced through wider application of bioeconomy approaches. Improving soil literacy in society would have only benefits both for soil management and bioeconomy. Next slide, please. So those most obvious synergies refer to optimized resource management, closing nutrient, energy, and biomass circles. So these are these obvious synergies between circular bioeconomy and soil management. So crop residues are used to produce soil amendments and co-products used in industry for instead of uh, resources are not cannot be recovered anymore. Like there are products of these processes like bio-oils, biogas, bioethanol, and there are also residues that can be used for soil amendments to improve soil properties or improve the carbon stock in soils. Phosphorus is another example, which is limited resource. It is produced from phosphate rock materials mined, and around 90% of that phosphorus rock is used in for food production sector. And there are different opinions, but there is a common agreement that phosphorus may be finished at a certain moment in some years. So we need to recover phosphorus that exists already in the environment, and it is somewhere in the waste produced in each municipality. So phosphorus is included in the list of critical raw materials, and there is a lot of phosphorus in bio waste that we can recover using innovative technologies of bioeconomy. Thank you. Next slide, please. We have to treat soil as a certain organism of connected characteristics, and taking care of one parameter, one characteristic of soil, one indicator will be beneficial for other characteristics of soil, like sustaining soil organic carbon will be beneficial for limiting erosion, avoiding compaction, and better soil structure, which is also beneficial for water retention in soil. Therefore, using soil amendments from bio-waste are that important for keeping soil healthy. And what are, for example, what is the role of improved soil organic carbon, for example, through soil amendments in drought prevention? This relates to retention properties of organic matter, but also positive effect on soil structure. Better structure means more water retention, greater resistance to compaction. This also results in a more soil retained, more water retained in soil, and even stimulation of biological activity of soil and microorganisms support plants in the periods of drought. I'm speaking about drought because this is increasing challenge for agriculture also in Poland. Next slide, please. Yeah, and this is we speak about bio-waste and soil amendments derived from safe bio-waste because also because of uneven manure availability of in regions and countries. Even in Poland, there are regions with high production of manure, and there are regions without almost without production of manure because there is no livestock in these regions. This means that classical type of exogenous organic matter must be replaced by something, another alternative resources, and treated safe bio-waste is a first example. Everything is connected with relatively low soil organic carbon in soils in Europe, in most of soils in Europe. I'm showing the map for bio-east countries in this case on the right side. Next slide, please. I mentioned drought challenge, so that's why this is so important to keep soil organic carbon, soil organic matter at certain level, and to keep soils structure at optimal state, and to keep soil health in general, because it is increasing and challenge. The map shows the frequency of drought reported in agriculture in Polish municipalities. So you can see that in certain regions it happens every year. So this is another potential synergy connection between bioeconomy, soil amendment production with a need to keep water retention in soils at certain level to help to survive the periods without precipitation. Next slide, please. So there are also some ideas of improved, enhanced biofertilizers, a bit more advanced biotechnologies based on nature-based solutions. So I'm showing here the idea of one of our projects, Innomic, to combine stabilized organic wastes like compost or digestates or biochar with pre-selected bacteria strains that are capable to support resistance of plants, crops against drought. And so that such combined biofertilizers can deliver humic acids, improving soil structure, water retention through addition of organic carbon to soil, and through plant resistance promotion activity of bacteria. So as a result, we assume that we can provide technologies improving plant resistance, also phosphorus solubilization in soil, and even contaminant decomposition, for example, contaminants originating from plant protection. Thank you. Next slide, please. This is the benefits resulting from compost application in agriculture and soil remediation. Agriculture on the left, so this is just example of our field studies, the effect of compost added to soil compared to liquid mineral nitrogen. This is especially visible in vegetation periods without sufficient precipitation. On the right side, there is an example of application of compost or biosolids for remediation of industrial waste deposits. In that case, very toxic smelter waste deposit containing high levels of zinc, lead, arsenic, and cadmium. So such constructed ecosystems can be persistent, but only if you provide organic matter like compost or biosolids with that water retention capacity and nutrients. Thank you. Next slide, please. Nutrients, this is another issue, very important in terms of soil, but also in terms of bioeconomy strategies and technologies. So we cannot forget about nutrients that are already in the ecosystem or in waste management. There's nutrients contained in compost, digestate, sewage sludges, biochars. There is a new concept of renewal. So nutrients recovered from manures, especially in regions where there is excess of manure, we can have technologies that extract, recover, concentrate nutrients that can be applied in another place. Struvite is another example of inorganic phosphate, for example, recovered from sewage sludge. Just example, when we what is the level of phosphorus in sewage sludge? Of course, it can be controversial to some people, but if we produce around 700,000 tons of phosphorus annually in Poland, they contain around 18,000 tons of nitrogen, 13,000 tons of phosphorus, for example. That would be sufficient to fertilize more than 600,000 hectares of agricultural land with phosphorus. So this shows the potential. Urban areas, cities could be a perfect example of that kind of circular organism connecting soil management and bioeconomy and urban waste management. So biowaste collected in urban areas is converted into soil improvers that can be used for kind of integrated space management, like management of green areas, soil fertilization and remediation. We create through soil amendments, we create healthy soils that are able to produce good biomass, healthy biomass, high biomass that improves living conditions or in cities through the activation of contaminants in the air or cooling effect. Next slide, please. So to going to the end, I wanted to just mention about our project, soil mission project, NB Soil, nature-based solutions for soil management. I'm speaking about this because everything is to do easier with a good advisory process. So the goal of this project, we are leading this project, is to develop innovative program of innovative learning pathway for existing or aspiring soil advisors. Next and last slide, please. And the central point of this project is to develop soil academy that contains 4 modules on how to treat and monitor soil, how to apply nature-based solutions, how to facilitate living labs and help farmers to test some soil management practices, how to support in decision making, what soil management practices can be applied, what is economically beneficial, and how to use digital tools in soil management. Thank you for your attention. I hope I did not speak too long.